some of the numerical problems based on ionic equilibrium. So example one is that calculate the dissociation constant of mono basic acid. So what is mono basic acid generally? What is the meaning of mono basic acid? The basicity of acid is 1, mono basic acid. Okay. So here basicity is 1, and what they asked to calculate here, calculate the dissociation constant of mono basic acid. That means what we have to calculate? Ka value we have to calculate. They asked to calculate Ka value. Dissociation constant of the acid we have to get, which is 3.5% dissociated. So alpha percentage is given here. What is given, ma? Alpha percentage is given. Then degree of dissociation. The degree of dissociation alpha is equal to what now? 3.5 by 100. So 3.5 by 100 we have to take alpha value. Alpha is what? Degree of dissociation which is given. Degree of ionization is given, and Ka value, degree of dissociation means constant of dissociation or ionization constant we have to calculate. Alpha is given. For which type of acid it is? Mono basic acid, like Ha. Ha means what now? Mono basic acid. It will produce only one H plus ion. Each molecule produces only one H plus ion. That's why it is mono basic acid. In N by 20 solution. So normality given what? 1 by 20 normal. 1 by 20 normal is given here. So 1 by 20 normal solution is given at what temperature? 20 degrees Celsius. Okay. So we need to calculate Ka value. C alpha is given and concentration C is given. Concentration C is given, alpha is given. So C alpha is given here. So alpha is given, C concentration is given, and we need to calculate what? Dissociation constant. For mono basic acid, normality is equal to what? Molarity. Normality of acid is equal to molarity of acid for mono basic acids, isn't it? Okay, so just a moment. Yeah. So here, for this, what we are asked to calculate here? Ka value we need to calculate. Ka is called what here? Dissociation constant of the acid. See now what is given? Concentration of the acid is given N by 20. That is 0.05 normal is given. So C value given here. What is given? This is called C. Concentration C is given. And out of 100 molecules, the number of dissociated molecules, how many given here? 3.5. 3.5% means what? Alpha percentage. Out of 100 molecules, only 3.5 molecules will dissociate into ions. Remaining will remain what? Undissociated molecules. Therefore, out of one molecule, the number of dissociated molecules. Out of one molecule, the number of dissociated molecules will be what now? 3.5 by 100. 3.5% given na? Per century. Percent is equal to 0.035 is alpha value. So this value is what now here? Alpha. So alpha is understood, C is understood here. So degree of dissociation is what? 0.035 alpha value. Substituting these values in the expression, Ka is equal to what? C alpha squared by 1 minus alpha. C alpha squared by 1 minus alpha. Okay. So here alpha value is very negligible in comparison to 1. So we can also neglect alpha, no problem. 1 minus alpha we can take 1. Otherwise we can take alpha value. So here C alpha square, C is what here? Concentration 0.05 alpha into alpha square by 1 minus alpha. If you neglect 1 minus alpha, means what? If you take 1 minus alpha equals to 1 also, nearly same answer will be getting. Because 0.035 is very less than what? 1. So it is what? 6.34 into 10 to the power of minus 5. What is this here? Ka value. Dissociation constant or ionization constant of the acid. Okay. So this formula is according to which law? Ka equals to C alpha square by 1 minus alpha is according to which law? Ostwald's dilution law. Ostwald's dilution law. So according to Ostwald's dilution law, Ka is equal to C alpha square by 1 minus alpha. So Ka we have to take formula what now? C alpha square by 1 minus alpha. Let's take the screenshot of this now. Next, here, so example 2. Calculate the hydrogen ion concentration. So what we are asked to calculate here, concentration of H plus ion we have to calculate. So calculate hydrogen ion concentration in 10 liters of 0.1 normal solution. So what is this 10 liters given here? Volume is given. So volume of acid is given, volume of substance is given, and 0.1 normal solution of an acid. So what is the concentration here? Concentration value given C, 0.1 normal. So 0.1 normal concentration C is given, and volume in liters how much is given? 10 liters. In this what we have to calculate? 0 means concentration of H plus ion. Solution of an acid having dissociation constant of 4 into 10 to the power of minus 10. So what is given? Ka. So Ka is given to you. Ka value is given. So Ka is given and C is given, V, volume is given. So H plus concentration we are asked to calculate. Okay, see here. The low value of Ka, that is 4 into 10 to the power of minus 10. So it is in the order of 10 power minus 10. So in the order of 10 power minus 10 indicates what? Very smaller value. So the low value of Ka, dissociation constant of acid, indicates that the acid is weak. The acid is very weak, and hence alpha is negligible. Alpha value we can neglect. Alpha value how much is, means for the alpha, whatever is given 1 minus alpha will take as 1 only. So in this case now here, if alpha is not very negligible, suppose in previous case you check it once. In previous case, what is the Ka value we got here? 10 power minus 5. 10 power minus 5, in the order of 10 power minus 5 we got. So it is not very weak acid, not very weak acid. But now it is what now? Another case what now? 10 power minus 10 Ka value. It is very lesser value. That's why alpha we can neglect. So Ka is equal to C alpha square by 1 minus alpha, and 1 minus alpha becomes equal to 1. Therefore, Ka is equal to C alpha square. It is for very weak acids. It is for very weak acids. Here K is what? Ka, dissociation constant of weak acid. C is concentration of weak acid. Alpha is degree of dissociation of weak acid. Now Ka value given to you. K value how much is given? 4 into 10 to the power of minus 10 is equal to C value given what now? 0.1 normal. 0.1 normal given, and alpha square. So alpha square, in that alpha we have to get. Okay, so first we have to get alpha value. So Ka value is given, C is given. From this, alpha square is equal to Ka by C. Ka by C. So then alpha is equal to 6.32. 6.32 into 10 to the power of minus 5 we get. So alpha value we get what? 6.32 into 10 to the power of minus 5. Alpha value. It is very lesser value. Okay, since 10 liters of acid have, okay, 6.32 into 10 to the power of minus 5 H plus. So alpha is given how much? 6.32 into 10 power minus 5 now. So if you take now Ha acid, it will produce what now? H plus ion and A minus ion, right? So if you take now here alpha, so here from C minus C alpha will be left over. Here C alpha left over, C alpha formed and C alpha formed here. Okay, so now here, since 10 liters of acid have 6.3 in 10 power minus 5 H plus, 1 liter contains how much? So this is what now here, 10 liters containing this much alpha here. Okay, this much H plus ion concentration. Then we have to get what now here in 1 liter how much? In 1 liter it will be divided by 10 liters. Okay, so here 10 liters contain this many H plus ions, then 1 liter contains how much? So cross multiplication. 1 into 6.3 into 10 power minus 5 by 10. It will be 6.32 into 10 to the power of minus 6 gram ion. Gram ion means what now? Mole only. Moles per liter. Gram ion means what? 1 mole ions. 1 mole ions equals to 1 gram ion. Okay, ma? So like this. Now here it is what now here concept is. Otherwise directly we can take H plus concentration equals to what now? H plus concentration C alpha. Now see how much? 10 power minus 1 into alpha how much? 6.3 into 10 to the power of minus 5. Okay, that is equal to what now here? 6.3 into 10 to the power of minus 6. This we get 6.32 into 10 to the power minus 6 what? Gram ion per liter, means moles per liter. So like this, H plus concentration is equal to C into alpha. First C is given here, and alpha value we have to get from this relation. Ka is equal to C alpha square. From this alpha we have to get first. Then alpha value into C will give what? H plus ion concentration. So if H plus ion concentration is known, can we calculate pH for this solution? pH is equal to what now? Minus log of H plus concentration. Now H plus concentration, how much we got? 6.32. 6.32 into 10 to the power of minus 6. Right, ma'am? So pH is equal to minus log of 6.32 into 10 to the power of minus 6. Now here minus log 6, how much, ma'am? Minus log of 10 power minus 6, how much? 6. So 6 minus log 6.32. Right? So here 6 minus log 6 value, how much approximately? Log 6 value, how much I told you? 0.8. 0.8 roughly. So log 6 approximately how much? No, 0.8. So 6 minus 0.8, how much? 5.2. So 5.2 is what now? 5.2 is what? The pH value of given solution. pH value of given solution. So sometimes pH also will be asked, continuation of this question. So first H plus ion concentration we have to get by the formula C alpha. After that we have to calculate pH. pH is equal to minus log of H plus ion concentration. Here minus log of 10 power minus 6 is 6 minus log 6.32. Log 6 value 0.8 roughly. That's why 6 minus 0.8, 5.2 is pH. 5.2 pH means acidic solution or basic solution. Acidic solution is formed. Let's take the screenshot of this one. Next. Example 3. Nicotinic acid, one weak acid. It is a weak acid. Okay, so nicotinic acid is present in tobacco. Tobacco contains what? Nicotinic acid. So with Ka value 1.4 into 10 to the power of minus 5 is represented by the formula HNiC. A H plus ion, NiC minus ion. It is what now here? Weak acid, monobasic acid. The basicity is equal to 1. Okay, calculate its percent dissociation. Means alpha percentage they ask here. So it's percentage dissociation in a solution which contains 0.1 mole of nicotinic acid per 2 liters. So how many moles in how many liters? 0.1 mole in 2 liters. In 2 liters 0.1 means in 1 liter how much will be there? In 2 liters 0.1 mole. Right, ma'am? Then in 1 liter how many moles? 0.1 by 2. 0.1 by 2. So 1 by 2 means 0.5 now. So 0.05 will be getting here. 0.05. So it is what now here? 0.05 moles per liter we can take. It is what now? Concentration. So concentration of this nicotinic acid given how much? 0.05 moles per liter. So C value, what is this here? C. It is equal to C. Concentration is given. Right now, concentration of the acid is how much now? 0.05 moles per liter. Moles per liter is what? Molarity. Okay. So now what they asked to calculate here? Alpha percentage. Calculate its percentage dissociation. Ka value given, C is given here. Okay. Now first of all, you see the solution of dissociation of what now? This nicotinic acid. So HNiC gives rise to NiC minus H plus. Initially, here 1 mole we have taken. Here it is C mole you take better. C moles we have taken 0 initially. And after some time, what happens when equilibrium is reached? What? C minus C alpha. So it is what now here? C minus C alpha is left over. C minus C alpha. The same thing, how to write? C of 1 minus alpha. C of 1 minus alpha is left over. And how much of NiC minus ions formed here? C alpha. And how much of H plus ion concentration is produced here? C alpha. Okay. So where alpha is the dissociation of the acid and C is the concentration of nicotinic acid. Now Ka expression for what here from this equilibrium reaction, products concentrations by reactant concentration. So we take here C alpha H plus ion concentration, C alpha NiC minus concentration divided by H NiC, left over how much? C of 1 minus alpha. C of 1 minus alpha. Here C get cancelled, then C alpha square by 1 minus alpha. Ka value how much here? C alpha square by 1 minus alpha. Okay. Now here C is what now? 0.05 moles per liter given here. So Ka value we can get now here. Ka value alpha square C alpha square by 1 minus alpha. So Ka value given how much? 1.4 into 10 to the power of minus 5. Substituting the values in the above equation, it is Ka value. It is given Ka. And alpha we have to get. And C value given how much? 0.05 moles per liter. Okay. So alpha we need to get. Right now. Now we can take cross multiplication here. So cross multiplication we can take here. So 1.4 into 10 to the power of minus 5 into 1 the same. Minus here 1.4 into 10 to the power of minus 5 alpha is equal to alpha square into C. Okay. So from this what we can get now here, quadratic equation we can solve. Or directly if you neglect this one also no problem. 1 minus alpha is equal to 1 also you can take nearly. Okay. So why we are taking 1 minus alpha completely here? Because we don't know whether alpha is very small or very large, we don't know. And Ka value is in the order of 10 power minus 5. It's not very weak. That's why we have to consider what 1 minus alpha also sometimes. If you are not able to solve a quadratic equation, directly you can take 1 minus alpha 1 only. Okay. So on usual calculations, alpha value we get what? 165.94 into 10 to the power of minus 4. That is 0.016594 is alpha value. But alpha percentage they ask na, that's into 100. Alpha value whatever we got into 100 is equal to 1.66 approximately. So once take the screenshot of this and practice this, solve this quadratic equation. Take the screenshot now. Yeah, now check it. Example 4. A certain weak acid has Ka value 1.0 into 10 to the power of minus 4. So dissociation constant or ionization constant of weak acid is given. And calculate the equilibrium constant for its reaction with strong base. So weak acid, we have to make it react with what? Strong base. This weak acid should be made to react with what? Strong base. Then what we have to get? Equilibrium constant for that reaction. So now the reaction of weak acid versus strong base we are taking like this. So let the HA be weak acid. HA is what? The molecule of weak acid. It is interacting with what now here? BOH, which is what now? Strong base. BOH is what? Strong base. The BOH dissociates completely into what? B plus cation, OH minus anion. So it is strong base now. Okay. And now here what happens now? In this HA, H plus will combine with OH minus. The H plus ion of acid combines with what now? OH minus to form H2O. Then which ion is left over here? A minus and B plus. So AB is what now here? Ba is what? Salt. Ba is the salt produced. So Ba is salt produced and H plus and OH minus combine with each other to form H2O. So it is what now here? Neutralization reaction of weak acid versus strong base. Okay. So now here HA plus OH minus gives rise to what now here? A minus and H2O. A minus and H2O. We can the same reaction we can write what now here? HA plus OH minus. HA plus OH minus gives rise to A minus and H2O. So B plus get cancelled here. Then we get what now here? HA plus OH minus gives rise to A minus plus H2O we get. Okay. So up to this understood here, it is the equilibrium reaction between weak acid and strong base. First of all. So what we have to calculate now? Equilibrium constant we have to get. Equilibrium constant. Equilibrium constant of this reaction what now? K is equal to product's concentration by reactant concentration. So what is the product concentration here? Here A minus H2O. H2O anyhow taken large excess. H2O is pure liquid we consider here. When pure liquid is taken, its concentration will be taken as what? 1. So A minus concentration by HA concentration into OH minus concentration. Okay, so what we take equilibrium reaction of here, K equilibrium. K equilibrium is equal to what? A minus concentration divided by HA concentration into OH minus concentration. A minus concentration is nothing but salt concentration. Okay, salt concentration by acid concentration into OH minus concentration. Okay, now let it be equation 1. Also for weak acid, how it dissociates HA gives rise to H plus A minus. For this equilibrium constant, that is ionization constant of weak acid, what? It is taken as what now? Equilibrium constant. For what? Reaction of for weak acid versus strong base. Now it is what now? Ionization constant. Ionization constant of weak acid. Ionization constant of weak acid is equal to what now here? A minus concentration into H plus concentration divided by HA concentration. Let it be equation 2. Now dividing equation 2 by 1. Equation 2 by equation 1. We get what now here? Ka of equation 2 divided by K of equation 1 is equal to A minus into H plus concentrations by HA concentration into, this will be taken as what now? It will be inverted. HA into OH minus by A minus. So we get what now here? H plus into OH minus. So here common things here HA, A minus get cancelled. Then what is left over? Take it here. H plus into OH minus is equal to KW. So H plus into OH minus is left over. So Ka by K is equal to H plus into OH minus we got. So Ka by K is equal to H plus into OH minus, which is equal to KW. So now what we got here from this equation here? Tell me Ka of acid by K equilibrium of weak acid versus strong base is equal to KW we got. Now what we need to calculate here? This one they asked here. K equilibrium we have to calculate. KW already we know. KW value we know. And Ka value given. Ka value given. So what we can get now here? K equilibrium is equal to Ka by KW. Ka by KW. So Ka is given in the order of 10 power minus 4 by 10 power minus 14 KW is equal to K. K is what? 10 power 10. 10 power 10 means very larger, very smaller, larger value. Means the reaction takes place in forward direction or backward direction. Previous equation, it will take place in forward direction. Okay, ma? So for this reaction, Ka value given 10 power minus 4. KW we know 10 power minus 14. So now K, how much we got in the order of 10 power? We got 10 power 10. That is what now large value of K equilibrium. So equilibrium constant we got 10 power 10. Please take the screenshot of this, ma. Next. So one more example is that 0.16 grams of N2H4. 0.16 grams. That is what now mass is given. So mass of the substance given here. And N2H4 is what now? Hydrogen. What is N2H4 called? Hydrogen. So what is the name of N2H4? Hydrogen. It is a weak base actually. Hydrogen is what? Weak base. Okay. So it is what? Weak base, remember. Now, so 0.16 grams of hydrogen, okay, dissolved in water. Dissolved in water, and the total volume of the solution is made up to 500 ml. So what is the volume of solution? 500 ml. That is 0.5 liters. 0.5 liters or 500 ml. So volume is given here in ml. Okay. Calculate the percentage of N2H4. Calculate the percentage of N2H4 that has reacted with water. Reacted with water in this solution. So what they have asked you? Calculate the percentage of N2H4 hydrogen that has reacted with water in this solution. Okay, the Kb of hydrogen is given 4 into 10 to the power of minus 6 moles per liter. Molar indicates what here? Moles per liter. So what we need to calculate? Calculate the percentage of N2H4. Okay, in this given solution. Now see, molarity of N2H4 solution is equal to, okay, 0.16 grams. It is what now here, 0.16 grams given weight by gram molecular weight. What is here? Gram molecular weight. So gram molecular weight of hydrogen, how much here? 32. Given weight, how much? 0.16. So number of moles into 1000 by 500. Okay, weight by gram molecular weight into 1000 by 500 ml. We know this formula, na? So what is the formula of molarity? Molarity is equal to weight by gram molecular weight into 1000 by volume in ml. This formula you know, na? So your weight by gram molecular weight into 1000 by 500 ml. That is 0.01 moles per liter. So what is the molarity of hydrogen? We got 0.01 molar. We got. Now N2H4 reacts with water. N2H4 is what? Hydrogen reacts with water in the following way. So let the amount of N2H4 reacted with water be alpha. So how much amount of N2H4 reacted with water we are taking? Alpha. Okay. So now amount of N2H4 reacted with water is what? Alpha taken here. Now hydrogen will interact with water, means undergoes hydrolysis to form what? N2H5 plus. N2H5 plus and OH minus. Here what is happening? Observe here. So from H2O to N2H4, one H plus proton will transfer. The proton, which is proton donor here, which is proton donor. H2O is proton donor. So proton donor is what? Bronsted acid. Which acid it is? Bronsted acid. So proton donor is called Bronsted acid. Proton acceptor is called Bronsted base. So hydrogen acting as which base here? Bronsted base. So it is Bronsted base, it is Bronsted acid. So from Bronsted acid to Bronsted base, what will transfer? Proton is transferring here. So after gaining the proton, it will become what? N2H5 plus. N2H5 plus. And after losing proton, it becomes what? OH minus. So this OH minus is what now? Conjugate base of H2O. And N2H5 plus is what? Conjugate acid of N2H4. We have discussed in Bronsted concept. Now see here. Now moles in the beginning. At start means what? In the beginning, we have taken how many moles of N2H4 here? 0.01. How many moles of N2H4 initially present in the solution? 0.01. So initial moles 0.01. And initially, this N2H5 plus 0, OH minus 0. And moles at equilibrium. At equilibrium from 0.01, alpha dissociates. C minus alpha. Okay, C value minus alpha. Okay, here how much is produced? Here alpha is produced and alpha is produced. And here we have taken water large excess. Large excess means we need not to mention how much is taken, how much is left over. Very less variation in the concentration will be there when you take H2O in large excess. So we need not mention about H2O here. Now Kb expression what for this equation now here? Here alpha into alpha. N2H5 concentration into OH minus concentration. Alpha into alpha divided by C minus alpha. Concentration minus alpha. Now Kb value how much is given for the N2H4? It is given 4 into 10 to the power of minus 6 is equal to alpha into alpha square by, here C minus alpha we have taken C only. So here C minus alpha is taken as what? C. As alpha value is very negligible here. For weak acids, we can take 1 minus alpha as 1, C minus alpha as C. That's all. So in this case, alpha square is equal to what now here? 4 into 10 to the power minus 8. Alpha square is equal to 4 into 10 to the power minus 8 we get. And alpha is equal to square root of this value. So 2 into 10 to the power minus 4 we get. So alpha value we got how much now here? 2 into 10 to the power of minus 4. Here what they asked to calculate the percentage of N2H4 that has reacted. Means what? Percentage dissociation they ask here. Percentage of dissociation. So percentage of dissociation of N2H4 reacting with water is what now here? 2 into 10 to the power of minus 4 alpha value into 100 by initially how much is taken mark? Out of 0.01 how much reacted here? 2 into 10 to the power minus 4 reacted. Okay. So out of 0.01 taken, how much is reacted? 2 into 10 to the power of minus 4. That's why what we have taken of here, 2 into 10 to the power of minus 4 into 100 by 0.01 here. So here 0.01 is what? Initial moles. From this initial moles, how much reacted here? 2 into 10 power minus 4 only reacted. So alpha value reacted how much here? 2 into 10 power minus 4. Is that clear, ma? So like this, we have taken what here? The reacted concentration into 100 by initial concentration is equal to 2%. So the percentage of N2H4 reacted is 2%. Okay. Take the screenshot of this, ma.